Chapter 9, Thermochemistry. Exercise 9.45. How much work is required to expand the volume of a pump from 0.0 to 2.1 liters against external pressure of 1.2 atm? Express your answer in joules to two sig figures. Alright, we can see there are two sig figures in the volume change, two sig figures in the pressure. So in the end, we need to keep two sig figures. We also need to know two things. Number one, the equation for work, which is negative P external times the change in volume. And also we need to know the conversion from atm liter to joule. Now let's work on this. First, the equation will be negative times P external times delta V. Delta V is V final minus V initial. So this is the equation for work, or expansion work in particular. So now we're gonna plug in the numbers. We'll get rid of this part. We'll get rid of P external, and we replace P external with 1.2, and this is in ATM. So I'm gonna use ATM here. And V final minus V initial, it's gonna be 2.1 minus 0.0 liters. So this is my setup. However, we need to convert atm times liter to joules, and there are two different ways to do it. One way is just you just look it up. It's 101.3, I believe. And another way is this: if you know how to convert atm to the SI unit of pressure, you can do that. Alright, you're looking at a very large number here, because 1 atm is 101.325 Pascal, and 1 Pascal is 1 Newton over 1 square meter, and this is actually in the SI unit of pressure. And we can also convert liter to cubic meter. A 1 liter is 0.001 cubic meter, because 1 liter is 1 decimeter cubed. So now we have this equation, and also we have the answer already. It's going to be a negative number because work is negative. Your system does work to the surroundings. But the question is this: how much work is required? So it seems it's asking about the amount of work. If that's the case, we just need the positive value here. I'm going to try negative value first, because over here it says work equals. I'm going to assume we're looking at the expansion of a system. The work must be negative. Okay. Alright, so it's indeed a negative number over here. Let's look at the equation. Negative P external delta V. Delta V is the change of the volume. So you can look at this. And by the way, if you know the conversion here, 1 liter times ADM is 101.3, you can use it right away. Over here, if you multiply this value and this value, you'll also get 101.3. Same conversion factor.